Hi! We're at Brooklyn Bridge Park in New York City celebrating the 4th of July with the Macy's Fireworks Spectacular. Many people come here to New York City to witness the largest fireworks display in the country. But we're here today to do some Carpool chemistry. Today, we're going to determine if a bond will be ionic, polar covalent, or nonpolar covalent using electronegativity. That is, will electrons be transferred, as in ionic bonding? Will electrons be shared, but unequally, where one atom pulls on the electrons with greater strength than the other, as in polar covalent bonds? Or will the electrons be shared equally, as in a nonpolar covalent bond? Let's find out using the concept of electronegativity. Let's say you have a potassium atom and a bromine atom that are going to be bonding. You take a look at the electronegativities of each from the electronegativity table. And for potassium, we have 0.8. So let's write that down. Electronegativity is 0.8. Bromine's electronegativity, as we can see, is 2.8. And I'm going to abbreviate this Eneg for electronegativity. So what we want to do now is we take the difference between the two electronegativities, that is, taking the larger value first, so we end up with a positive value. We're taking the absolute value, 2.8 minus 0.8 is equal to 2.0. This is our difference in electronegativity. And if we look at the charts, we could see what happens if you have a difference of electronegativity of 2.0. That lies between 1.71 and 4.0. Therefore, this is going to be an ionic bond. That is, the bromine with such a high electronegativity compared to potassium's basically draws all the electrons away from potassium, or actually the lone electron in the case of potassium, since it only has one in its outer energy level. So from the charts, this would be an ionic bond. Let's take a look at another example. We have sulfur and we have oxygen. The electronegativity of sulfur is, taking a look back at the table here, sulfur clocks in at 2.5. Oxygen is 3.5. We take the difference between the two, 3.5 minus 2.5. Once again, we list the larger value first, so we come up with a positive number, and the difference is an electronegativity of 1.0. Looking at our chart, we see that 1.0 lies between 0.31 and 1.7. So this is a polar covalent bond. That is, they're sharing electrons, but they're sharing them unequally. So from the chart, we see that's a polar, P-O-L-A-R, covalent bond. And then these are shares electrons unequally. And so if we take a look at an oxygen atom and a sulfur atom, if they're bonded together, because oxygen, even though they're sharing the electrons, because oxygen has a higher electronegativity, it's attracting those electrons with greater strength than sulfur is, and so those electrons are going to be slightly shifted towards oxygen. As a result, this side of the bond becomes slightly negative, and this side of the bond becomes slightly positive. Back to our ionic bond, we could say that electrons here are basically transferred. Let's take a look at one more example. Selenium and sulfur. the electronegativity of selenium is, from our chart once again, selenium we have 2.4, and sulfur we have 2.5. Very close to each other. They're attracting electrons with similar strength. Let's find the difference. Once again, the larger number first. 2.5 minus 2.4 is equal to 0.1. And from our chart, 0.1 clocks in at a non-polar covalent bond because it's between 0 and 0.3 electronegativity difference. So non-polar covalent bond, they share their electrons equally. Once again, because their electronegativities are close together, electronegativity being a measurement of an atom's ability to attract electrons, they're very close to each other, so they're tugging at them with equal strength, they're sharing them equally. And that's how you determine if a bond will be ionic, polar covalent, or nonpolar covalent using electronegativity. From the 4th of July Fireworks Spectacular in New York City, this is Carpool Chemistry. Thanks for watching.